Alright, first section of Chapter 9, Miss Olson and I's favorite chapter. We're going to start talking about quadratics, and this section will be pretty straightforward. It kind of just serves as an introduction to quadratics and their graphs and equations. So quickly just get out the vocabulary. Quadratic function is any function in the family with a parent function x squared. So we've already learned about this in Chapter 8. We call them parabolas. And I have some examples down there for you to write. All of those examples are examples of quadratic functions because they have the parent function x squared. They're all that parent function just slid over or reflected or shrunk or stretched or something like that. The general form for a quadratic equation, which we're going to have to teach you how to write this, all equations in this form, is y equals ax squared plus bx plus c, where a does not equal 0. So this is just like we always write linear equations in y equals mx plus b, we're going to always write quadratics forms in ax squared plus bx plus c. And of course a cannot equal 0 because then the x squared term would disappear and we would just have bx plus c, which would be a linear equation. Just got a picture here to remind you of what parabolas look like, simply because anytime you see something that's this sort of shape, you'll know that you can write it out of the form y equals x squared, and you know that it's going to be a quadratic function. Alright, a lot of our examples that we're going to be working through with quadratics have to do with projectile motion. And this is kind of like the example when you throw a ball up into the air. So if you throw a ball straight up into the air, its height, so how high it is above the ground, depends on three things. It depends on where it starts, so probably about how tall you are. The velocity at which it leaves your hand, basically meaning how hard you throw it and which direction you throw it in, and then the force of gravity. Earth's gravity causes objects to accelerate downward, gathering speed every second. That just means everything is affected by gravity. It's pulled down to the ground. This acceleration due to gravity, called g, is 32 feet per second. That's going to come into play later, and that just means that the object's downward speed increases at 32 feet per second for each second that it's in flight. So we've just got our first example here, a baseball batter. They pop a ball straight up. So the ball reaches a height of 68 feet before falling back down. Roughly 4 seconds after it is hit, the ball bounces off home plate. The graph below models the height of the ball over time. When is the ball 68 feet high, and how many times will it be 20 feet high? So as I'm looking at our graph here, I notice one thing that we talked about that it affects the height of the ball is where it started. And I can see that it started, something that you might want to note is that it started at about 5 feet. Okay? And then I can see here that it's quickly accelerating. The height is getting further and further off the ground, and then it kind of slows down until it reaches its peak right about here. So it says, when is the ball 68 feet high? It told us that the maximum height is 68, and I can see that that's right at about 2 seconds. So it is 68 feet high at 2 seconds. And how many times will it be 20 feet high? Well, if I look at the height of 20 feet, right here, okay, it's going to be there 2 times. So it's a pretty easy question to answer. It's going to be at 20 feet when it's on its way up, and it's also going to be 20 feet when it's on its way down. So it will be 20 feet high twice. Okay? And example B. Solve the following equation symbolically. So we want to go ahead and basically solve for x. What they mean is we want to figure out what x equals. So I want to just go through what the process will be for a problem like this. First thing you're going to get rid of is the constant. So that would be this minus 10. So I'm going to add 10. And I'll get 5 times x plus 2 squared equals 37. Now I just want to get rid of any coefficients, and in this case 5 is a coefficient. I'm going to divide by 5, and I'll get x plus 2 squared equals, and I'm going to go ahead and just divide this out. 37 divided by 5, that's going to be 7 2/5, which I know equals 7.4. Okay, and then we're going to go ahead and get rid of the exponent here and the square root each side, and I'll get x plus 2 equals the square root of 7.4. And you could calculate this out if you wanted to. I guess I could grab my calculator here. Gives me about 2.72, like that. So then I subtract 2 from each side, and I get that x equals approximately 0.72. Alright? So go ahead and try this other example. It's not on your note sheet. You're going to have to copy it down. I want you to try this example before you come to class tomorrow.